Hi everyone, here's a really quick video on a recap on finding what's called the nth term of a linear sequence. Now, let's start with some of those words there. How do we know that this is a linear sequence? Well, we start by looking at the gap between the sequence. So we're looking at and asking ourselves, what happens between 7 to get to 10? Well, we add 3. And then we do the same for the next two terms. So from 10 to 13, again, we add 3. And if we spot the pattern throughout the rest of the sequence, we can see that that's a common difference, that we're adding 3 each time. When this gap remains constant, i.e. it's the same amount each time, this is what's known as a linear sequence. So how do we find the nth term for a linear sequence, which in our language means what's the rule for this sequence? Well, we start with an n, and n stands for the position number in the sequence. So I'll come back to that in a minute. And then this gap, this number here, and notice I've put +3, that's really important because it's not just that the gap's 3, it's that it's increasing by 3. This gap goes here in front of n. So our rule now says 3n. Now this says that this rule is part of the 3 times table. It's going up in 3s. So we need to ask ourselves, what is the 3 times table? Now let's come back to n. n stands for the position number, and here n equals 1 because this is the first position in the sequence. Here n equals 2, here n equals 3, n equals 4, and n equals 5. And our rule's telling us to do 3 times whatever n is. So where n is 1, we're doing 3 lots of 1, which is 3. Here n is 2, so we're doing 3 lots of 2, which is 6. And we carry that on, so 3 lots of 3, 4 lots of 3, and 5 lots of 3. So this is the first part of our rule. If we had this as our rule, if we had 3n as our rule, we'd end up with this sequence here. But we want this sequence here. So we have to ask ourselves now for the second part of our rule, what do I do to get from here to here? How do I get from 3 to 7? Well, it looks like I add 4. Let's check that works with the next one. If I add 4 to this, do I get this? Yes. Add 4 to this, do I get this? Yes. And so on and so on. So an expression for the nth term of my linear sequence is 3n plus 4. Let's check if the rule works. So using the sequence, let's have a look. What would be the next number in this sequence? If I carried on again, if I added 3 one more time, this time to 19, I'd end up with 22. And this would be the 6th number in my sequence. So n would be 6. So let's see if this works. If I put a 6 in there, 3 lots of 6, add 4, well 3 lots of 6 is 18, add 4 equals 22. Was that the number that was next in my sequence? Yes. So my rule here works for the next term in the sequence, so an expression of the nth term for this linear sequence is 3n plus 4.